Let us study the expression of escape velocity with the help of law of conservation of energy. With the help of a diagram, we will solve it. This is the earth. This is its center. This is the surface of the earth. Here I am keeping an object with mass small m. From the center towards the surface, radius is there, radius of the earth r, or we can say from the center towards the surface, how much distance is there, that we can write as capital R. That is the radius of the earth. Capital M, that is the mass of the earth. Now we are throwing the object with the escape velocity. So we can write the Ke. Ke means kinetic energy possessed by the body. And on the surface of the earth, if the object remains, potential energy possessed by the body. Both of them we have to write now. Again we can say that total energy possessed by them we have to find out. Now Ke, that is equal to half mv square. Potential energy is equal to minus capital G, capital M, small m upon capital R. Here now the sum of, that means total energy possessed by the body, will be equal to E. E means what? Total energy possessed by the body. Now similarly here, once when we throw with escape velocity, the object reaches at infinity. This is the symbol of infinity. Infinity means undefined area. That means we don't know means where it is, how much distance it remains. So it is an infinity. It is at the infinity means very heighted region. That region we cannot be able to define. Now once it is reaching there, there will be no gravitational force. There will be no velocity to that particular object. That object will be remain in the stationary condition. Stationary means without any movement. So we can say that here velocity will be equal to 0 as well as g, that is gravitational force exerted by the earth, that also will be equal to 0. As a result of it, Ke is equal to 0 here and Pe also equal to 0 here. Then the sum of Ke plus, sum of means both of them we have to add, Ke plus Pe at infinity will be equal to 0. So here now total energy possessed by the body when it is at the infinity, we can say that when it is reaching at infinity, when we throw the object with the escape velocity. With the escape velocity, if we throw, the object reaches a certain distance from here. The object is going and it is reaching at this particular place. Here it rests without any movement, it remains there. So that particular time Ke will be 0. Even there will be no gravitational force exerting by the earth. Because of that, Pe also will be 0. Now we people are studying about the position of the object on the surface of the earth now. When the object is on the surface of the earth, then what will be Ke, what will be Pe? Ke means kinetic energy, what will be its potential energy? Let us see now. Here now, this is the total energy possessed by the body when it is at the infinity. So here total energy, for that I am writing E2 is equal to. E2 is equal to Ke plus Pe. Now if I am removing this, E2 means what? Ke plus Pe. Now again I am writing here Ke is equal to how much? 0. Ke is equal to 0. That means E2 is equal to 0 plus 0. 0 plus 0, that is 0. So we can say that total energy possessed by the body when it is there at the infinity will be equal to 0. Now we are finding total energy possessed by the body when it is on the surface of the earth. For finding that, K means Ke is equal to half mv square. This is now v means escape velocity is there. So I am writing here escape velocity. That is escape I am writing. So with the escape velocity we thrown the object. Now Pe, that is potential energy possessed by the body when it is there on the surface of the earth. That is equal to minus capital G, capital M, small m upon R. Now we are finding E1. This is now we are finding total energy possessed by the body when it is there on the earth, on the surface of the earth. So E1 is equal to, because here I written E2. Now I am writing here E1, that is equal to Ke plus Pe. Now here E1 is equal to Ke means what? Half mv square. Mv means v, that is escape velocity, plus Pe means minus capital G, capital M, small m upon R. Now here you see we are totaling both of them, Ke plus then Pe. Now what will be our answer? E1 is equal to half mv square. V means escape. Then plus into minus, minus G m small m upon R. Now here this E1 I am removing, then how it will be? Half, if we are finding their sum. Now we are finding the sum of which one? E1 is equal to Ke plus Pe. So we have total, we have got the answer now. E1 is equal to, E1 means the total energy possessed by the body when it is there on the surface of the earth. So equal to how much? E1 is equal to half mv square minus G capital M small m upon R. Now I am writing it little more easy way or easy to understand. So how I am writing, you see. Now half mv square I am writing as mv square upon 2. mv square, that is upper part gone. Here 1 is there. So I written as mv square upon 2. Then minus, here what is there? G capital M small m upon R. So here again I am writing E1 is equal to. Now here I am writing now this V square I am separating. So here I am writing now V square is equal to. Now this we are taking to, one more thing I am saying. Here now mv square upon 2 minus G capital M small m upon R is equal to 0. Now these two I am bringing, V I am taking to that side. So how it will be? M upon 2 minus G here. When I remove this m upon 2, I am keeping here, V I remove there. Then the formula will be like this. V square I am keeping here. V square is equal to. Then this 2 will go up, this side upside, and m will come down. Then V square is equal to minus value is not changing. Then this m I am taking to that side. So as well as 2 I am taking. Then 2 G capital M small m upon, then here this 2 gone upside, m is coming down. Then here r is there, so m into r. So listen here, in the formula half mv square minus gm m upon r. Now again from this, here half mv square is there, so that I written like mv square upon 2 minus g capital M small m upon r. Now I am separating the v square here. So one more thing before that, I am writing it as this E1 I removed. Now it is made in the equation form. That is mv square upon 2 minus g capital M small m upon r is equal to 0. Now what I am doing, this v square I am keeping this side, then here division form is there, so 2 will go upside, m will come down. Then how it is, v square is equal to 2g capital M small m upon small m into capital R. Now this m and this m I cancelled. Then what will be our answer? V square is equal to minus 2 capital G capital M upon R. Now we have to find out the value of V. V means what? This is the escape velocity. Escape velocity. Here also escape velocity. Now we are finding V. V means what? V is equal to square root of minus 2g capital M upon R. Now we have to simplify this equation. So for that we will take the value of a small g here. Now what is the value of a small g? Small g is equal to capital G capital M upon capital R square. Now here capital R square is there, but here only one R is there. So we have to make this R in the form of square. For that I am multiplying up and down with capital R. Then how our formula will be there? V is equal to square root of minus 2g capital M upon capital R. Here this R I am multiplying with here. So capital R here. Again this R I am multiplying here. Capital R. So we can write it in such a way, that is square root of minus 2g capital M capital R upon R square. Now children, here g m upon r square, that means what? Small g. So I am removing this value and I am putting the value small g here. So listen, here it is equal to, that means escape velocity. V means what? Escape velocity. Here again V means escape velocity. It is equal to, escape velocity is equal to square root of minus 2. Now gm upon r square. For that I am writing the value small g. Afterwards what is left out? Capital R. So now we have got the answer. Escape velocity is equal to square root of minus 2 into g into capital R. If we want, then we can be able to substitute the value of g and substitute the value of r then we can find the escape velocity. So here now only I derived, okay, derived, or we found the expression of escape velocity here. Thank you.